The first instructional video for fluid dynamics is on why objects float, what it means when they float, what it means when they sink. So when asked what determines if an object floats in water, the most common answer is it weighs less than water. But that's not always the case. And truth be told, density does play a role in determining whether or not something will sink or float, but not as big as a role as people think. For example, the shape of an object plays the bigger role in the matter, because if we take a steel ship, for example, steel is much more dense than water itself. In fact, it's 8 times as dense, yet it can still float on water. Another thing that people tend to forget is that water is actually very heavy. So for example, if you take a 10-minute shower, that's an average of about 25 gallons of water. That 25 gallons of water was held in your hot water tank. It weighed over 200 pounds. So what is the right answer? It's actually a combination of a lot of different things. Yes, density does matter, but not as much as people think. Shape is the bigger factor. Shape causes displacement, and displacement is what determines whether something is going to sink or float. The density of the object determines the displacement required. Also, the density of the fluid does play a key role. For example, many metals will float in liquid mercury because mercury is extremely dense. So, by definition, if something floats in a fluid, the weight of the displaced fluid is equal to the weight of the object. And while that is at the surface of the fluid, most of the times we'll be dealing with water, the buoyant force is equal to the force of gravity. And by definition, if an object sinks, the volume displaced in the fluid is equal to the volume of the object. Now, if we have a sunken object resting at, say, the bottom of a lake, an ocean, or any kind of container with a fluid in it, the buoyant force does not equal the force of gravity. Neither does the normal force. Both the buoyant and normal force combined act upwards, countering the force of gravity acting down. And this is why objects appear to weigh less in a fluid. So in this picture here, we have 5 objects, A, B, C, D, and E. We'll focus on objects A and B to start. Let's say objects A and B were the steel hull of a ship. We look at object A, it's pushing the water off to the sides of it and underneath it. Therefore, it gets to float. Object B, since the water went over the lip of the hull, it flooded the ship. Therefore, the ship could no longer displace as much water as it had previously. Now, if we take it something just geometrically sound, such as a cube, a solid cube, as we see in C, D, and E. In C, D, and E, we can definitely declare, based on their shape, if they are solid, that C is more massive than D and E. D is the least massive of all the objects. For A and B, though, because of their unique shape, we can't declare which one's more massive. Now, last type of question I have for you, a conceptual question. We see we have a tank of water filled here with the hull of a boat put into the water, and a steel ball is placed inside the boat. Over here on the left, we see this orange line that tells us what the water level is. What we're going to do is we're going to take the ball, throw it overboard, and let it sink to the bottom. And the question is, what's going to happen to the water level? Will it rise, fall, or stay the same? The water level is actually going to fall. So we see here we started, ball's in the water, water level has gone down. Why? Well, when floating, since an object that floats displaces as much water equal to its weight, and the ball was made of steel, we needed 8 globes of water in order to equal the weight of one steel ball, which is a lot of displacement. But when it's at the bottom, the volume of the steel ball is all that is displaced of the water. Thank you for watching.